Alright, so this is just a specific heat problem, and so what I'm going to do is I'm going to go over the formula with you again, review the units, and then do this specific problem. And so as soon as you start a problem where it's asking about joules, which is heat, we're going to be using this formula. Q equals mc delta T. Now, just for you to remember, Q is going to be your heat, and heat, for the purposes of these problems, is going to be in joules. Now, if it's not in joules, if I give it to you, you would first have to convert into joules using the energy conversion, like from calories to joules or kilojoules to joules. This unit right here is your mass. Mass for these problems is going to be in grams. Okay. I'm going to skip C really quickly. Delta T is your change in temperature, so it's your final temperature, which is TF, minus your initial temperature, which is TI. Okay. And then for C, if you notice, I want in this equation right here, I want it to end up with units just of joules. So I have to find some way to get rid of my units of grams. And for temperature, it's degrees Celsius. And the way that you do that, you put joules on top, because it'll end up being in joules. And then you're going to put on bottom grams and degrees Celsius so that they'll cancel. So grams and degrees Celsius. And so the grams cancel, the degrees Celsius cancel, and I'm left with just joules. So for this problem here, it's asking for how many joules. So I'm solving for Q. So I'm going to put Q equals, we don't know. Okay. Are required to heat 5.25 grams, so that's the mass. Five grams. Alright. And you're going from 85 degrees to 302. So my change in temperature is TF minus TI. So TF, my final temperature, it ends at 132.5, starts at 85.5, and so what I end up with is 132.5 minus 85.5, and I get 47. So my delta T is 47. Now, if it had decreased in temperature, so gone from 132 to 85, my delta T would have been negative, which is perfectly fine. Okay. And then C, which is your specific heat capacity, is given to you. It's 0.523 joules over gram degree Celsius. Okay, and this unit is degrees Celsius, so I'm just now going to plug everything in and solve. So my Q, I don't know what it is, equals my mass, which is 5.25, times my C, which is 0.523, times my change in temperature, which is 47. And so I'm just going to multiply this whole thing out. And so I get 5.25 times 0.523 times 47. And I get 129.05. For sig figs, look back at your original problem. Since I'm multiplying, that has 3 sig figs, that has 3, that has 4, and that has 3, so my final answer needs 3. So I'm going to round the 129.05 to just 129. What you'll notice is that the units for grams cancel with the grams on bottom for the C, and the degrees Celsius cancel with the degrees Celsius here, and so you're just left with joules. And that's your final answer. Okay. Just one other conceptual thing that I could ask you guys. When we're dealing with this formula Q equals mc delta T, a real live application of this has to do with things getting really hot or not getting hot. Okay. So for example, the example I gave in class was sitting at a pool. Now, the pool water stays really cold, or reasonably cold, while the metal around the pool can get super hot. Now, they're exposed to the same amount of heat from the sun, so this stays the same. Okay, it can't change. So what you'll notice is that since the specific heat for metals is really small. In order to keep the Q the same, the T, the change in temperature, is going to have to be really large. And so as a result, since metals have a really small heat capacity, their temperature changes quite a bit when they're exposed to a certain amount of heat. For water, water's kind of weird. It has a super large heat capacity. So when it's exposed to the same amount of heat as the metal, its temperature is going to only change a little bit. And so that's why in the summer you want to avoid anything metal because it has a really low heat capacity, so it gets really hot. While water, you want to be near water because it has a very high heat capacity, which causes the temperature to change very little. And that's it.